Hello folks, in this video I'm gonna be showing you how wheels and tracks of a tracked vehicle should be set up in Blender to be exported into a Battlefield 2 object, Battlefield 2 file. I'm gonna be using Ekisos, I hope that's the correct pronunciation, BF2 add-on for Blender, and this vehicle Tosan IFV is gonna be part of the Iranian army faction for Project Reality, and I'm recording this on the recommendation of Refractor, one of the Project Reality developers. Hope it's the correct pronunciation again, sorry if it's not. So let's dive into it. I have hidden all the unnecessary parts. I'm gonna be focusing on the GM1 and how the tracks are set up. Let's first just take a good look at how the hierarchy, at least this part of the hierarchy, is set up. I suppose you know the rest. If not, you can check the add-ons, the documentation. It's up on GitHub. I'll be linking it down in the description anyways. So the first object, the GM1 object, should have the player control object object type. You have to pay attention to the case of the letters. So onto the next object in the hierarchy, it's the motor object. It has to have the engine object type. It's basically just a triangle. It controls all the movements of the vehicle, I think. Next parts are the wheels. As you can see, there's tons of them because it's a tank. It's an armored vehicle and they have tons of wheels. But as you can see, only the drive wheels and the wheels in the front, which I have not figured out what they are called actually, are only these objects are actual objects with mesh data. The rest are null objects. I think we can call them the null. They don't have any mesh data at all. No polygon, no faces, nothing. I will get back to them in a minute. So first I better explain the object type for them. So when you see a wheel, whether it would be for a truck, for a tank, or for a jet's landing gear, when you see them go up and down, they actually are it's because of the fact that they have the spring object type. So what it does is that it makes the object correspond to the terrain and the obstacle. So if the vehicle goes over a terrain, it goes up, for example, and then it goes down. And I think now we can start the track motion explanation. So the tracks in the game have two types of motion. One is the track translation, the forward and backward motion, and one is the track deformation. When the vehicle goes over an obstacle, some parts of the track would go up, then the next part, then the next part, until it's on the even ground again. So each of these motions are done via different methods. So the first motion, the forward and backward motion, is done via animated UVs. So what it does is it moves the UVs of the object front and back. So it would kind of simulate the movement of the track. The actual mesh doesn't move, but the UVs move. Let me show you. This is not exactly what happens next what I'm gonna show, but it's something similar. So as you can see here, let me disable this. As you can see here, when I move the UVs, they look as if they were moving, if the actual track was moving. So that's basically what the engine does. When the vehicle moves, it animates the UVs so it would seem like that the tracks were moving forward and backward, for example. That's the same, this exact same technique is used for the wheels. There is another technique to show the rotation of wheels, which is used on these wheels. I'll get to them later, but for performance sake, and I think it's more simple personally, we use animated UV for the road wheels here. So what it does is pretty similar to the tracks. Let me select these. So when the vehicle moves and the wheel should move too, the game basically just rotates these UVs. As you can see, it looks like it is moving, but in fact it's not. And then there are the other parts of the wheel which have rectangular UV islands. I will get to them later. So first, for the track, it's pretty simple to set it up. You just select, first you select one side. I selected the left side. You come to the mesh tab, you go down here to BF2, and down here assign to left track translation, and you do the same for the right track. Assign to the right track translation. Then you can check if you have assigned them correctly by going to select tab, BF2, select left track. As we can see, these are all left track parts, and then do the same for right track. Now for the wheels rotation, you first just select left wheels. I selected the left wheels first. These parts have the same texture as the other side, so they have to be rotated like them. Select all of them, then you go to the mesh menu, BF2, set left wheel rotation, and then you have to, while these are selected, you have to do the same for the right wheels. The left wheels shouldn't be selected, only the right wheels, and whatever part you want. Then go to mesh, BF2, assign to right wheel rotation. And for those parts that I said, we will get to them later, the parts that have rectangular UV islands like these, and all the other parts except the center parts, you have to select them, go to mesh, BF2, assign to left wheel translation this time. So it should be translation for the parts with rectangular UVs, and rotation for these parts with circular UVs that actually need to be rotated. And one thing I almost forgot, let me select these, select left wheel translation, select left wheel rotation, then select the right wheel too. While these are selected, you have to go to the UV tab, UV editing tab, and from the mesh menu here you have to set animated UV rotation center. This tells the engine that around which point the UVs, the UV islands, should rotate. So what you have to do is to select all the UVs that are assigned rotation, that are set to be rotated in animation, and then go to the UV sheet and press Shift plus S while you have selected the UVs, press Shift plus S and press cursor to select it. This moves the 2D cursor to the center of this UV island. It should first be like down here, then it should come up here, and then you have to hit Mesh BF2 set animated UV rotation. Otherwise it will look messed up. It would look like something like this in the game. You see, that's just not right. Okay, that's all about animated UVs. And now let's go to the up and down movement of the track and wheels. So it is done via a method called skinning. It's basically what animators would call rigging. It's to parent some vertices to an object so they would kind of copy the movement of that object. So for this we have these objects which I explained before that have a spring object type. So they would actually react to difference in terrain. They would go up, they would go down. So we want this movement to be copied into certain parts of the track and wheels. So to do that we have to select the mesh, the object that they are part of, and then we have to, as you can see here, we have to make vertex groups for each of these objects up here. So if we want some vertices, for example these vertices, to move with left wheel 2 like this or that or something like that, we have to make a vertex group, name it exactly the same as the target object, just copy and paste it here, and then assign the vertices you want to them. So going to weight paint view to show it better, you can see that this whole wheel and parts of the track and these parts of the suspension system are assigned to left wheel 2 vertex group. So they would, in the engine, they would go up and down according to the left wheel 2 object. Same with every other vertex group. The important note that you have to keep in mind is that because of the fact that Refractor 2 is a 20 years old engine, it has some obvious limitations. One of them is that in bundled meshes, each vertex can only be assigned to one vertex group. So for example, this vertex that I have selected cannot be part of this group, and for example this group too. It should only be part of one of them. So that's an important note to keep in mind, so you don't face errors while exporting. So that's basically it. Now I'm just gonna explain these, how the rotation for these work. As you can see, these have actual detailed teeth, and it has some parts here too. So these cannot be faked with animated UV method. They should actually rotate. So in order to do that, you have to set the rotational bundle object type for them. I say again, you have to pay attention to the uppercase and lowercase of the letters. I think you can find all the different object types in the add-ons GitHub page, GitHub documentation. So that's basically how you have to do it. The rest is done in code, which I am not yet proficient in. Actually, Aladdin, one of the Project Reality developers, fixed our code, so it pretty much works perfectly now in the game. I think that's all. In order to be able to actually export it, you have to set up the hierarchy. You have to have geom1 and all this stuff, geom0 and geom2. This is not final, so I have just made some objects and set them for the sake of being able to export. So after that, after everything's done, you select bundle mesh, the root object, go to File, Export, bf2.con, and just hit export, and it should work fine. Now you can code it and have fun in the game. Please let me know if I forgot anything. If you have any questions, I'll answer them in the comments, and have fun.